Okay, so we're going to do the basic overview of what a radical is. So another word for a radical is a square root, but I'm going to use the term radical because that's what high schools use. So by now you should know that 4 to the second power equals 16 because this is basically 4 times 4. You also say it as 4 squared. So 4 squared equals 16. So that's where the idea of the square root comes. Just like in algebra, the opposite of subtracting is adding. So the opposite of taking a square is taking the square root. So the square root of 16 is 4. Because 4 times 4 is 16. Notice how it's a pair of numbers. We always look for pairs of numbers. So let's try this one. The square root of y squared. Well, y squared is y times y. That means there's 2 y's. So my answer would just be y because we're finding the pair and there's one pair of y's. So the square root of y squared is y. Again, just like 16, because 4 times 4 is 16, that's the pair of 4's, so the answer is 4. Okay, we're going to move on to a harder one. How about 45? So this doesn't go in evenly, so I'm going to have to factor it out. So there's more than one way. I know that 9 times 5 is 45. 15 times 3 is also 45. You can use that and you'll end up with the same answer. So 9 times 5 is 45. 5, only 1 times 5 is 5 because it's prime, so I'm going to circle it. Now 9. I know 3 times 3 is 9, and it can't go any further because 3 and 3 are prime. All right, do you see any pairs? I see a pair of 3's. So 1 pair of 3. So I can pull out a 3 because that represents the pair. But notice how I have this 5 left over. So that stays in the radical. So 3 radical 5 is my final answer. Let's try another one. Again, pause the video if you need to go slower. All right, 350. Again, it doesn't matter where you start. I'm going to start by tens because I see it ends in a 0. So 10 and 35 make 350. I can keep going. 5 times 7 can make 35. I'm going to circle those because those are prime. 5 and 2 make 10. Now I look for a pair. I see there's a pair of 5's. So the 5 is going to go on the outside of the radical. But what's left over? The 7 and the 2. 7 times 2 is 14. So 14 goes inside because there's no pairs. So 5 radical 14 is my final answer. Okay, let's try one with variables, then we'll put it together. All right. So, square root or radical, x to the 6th power, y to the 9th power. This means here there are 6 x's. How many pairs can I make with 6 x's? 1, 2, 3. So x cubed will go on the outside. That represents the 3 pairs that I can make. All right. Now y to the 9th mean there's 9 y's. How many pairs can I make? 1, 2, 3, 4. I can make 4 pairs. And look, there's 1 left over. So my final answer, I can make 4 pairs, so it's y to the 4th, but there's 1 y left over. So all of this is my final answer. X cubed, y to the 4th, radical y. All right, let's put it together. This is the hardest one. 48. X to the 13th. All right, let's do the 48 first. 48, one way is 2 times 24. I'm going to circle the 2. The next one, 12 times 2. Again, circle the 2. It's prime. Then 4 and 3. Circle the 3. It's prime. Lastly, 2 times 2. All right, let's find some pairs. I see a pair of 2's right here and a pair of 2's right here. So there's 2 pairs of 2. So 2 times 2 is 4. Now I have a 3 left over. So in my radical, I'm going to leave the 3. Let's go up to the x's. There's 13 x's. So pairs are by 2. So if I have 13 x's, 2 times 6 is 12. So I can make 6 pairs with 1 left over. So then it would be 4x to the 6th with 1 left over x. That would be my final answer. Please let me know if you need more material.